Welcome to this session on Introduction to Analytics by EquiSkill. Data. We've all heard about data, and there's a lot of sources of data. As you can see on the right hand side, it might be transport, it might be locational data, it might be scientific genetic data, financial data from the stock markets. But what is data? And data is derived from a Latin term that means a single fact, a single entity, or a single point of matter is data. Now, today, a collection of many pieces of data is called a data point. Data is a collection of data points. The original word is actually datum, which is a Latin word. Data is a single fact, a single entity, or a single point of matter, but very often you see data being clubbed together, which isn't a very great practice. So if you notice, for example, here, that every cell contains two data points, not one. Now this is not clean data. You see currencies as well as amounts together, which is not one single entity. There's actually two entities in there. So the ideal practice would be to have different fields or different columns, if you might call them in Excel, or different variables, as we might call them in analytics, to store the amount as well as a currency, which are both different data points, as you can see here. There are actually fundamentally three types of analytics, and you may have heard of many different types of analytics. The most fundamental are descriptive analytics, which is what you see right at the bottom of the pyramid here. Above that, you've got predictive analytics. And then finally, you have prescriptive analytics. Now we're going to try and understand what are these three different types of analytics and what might they actually mean. So let me start off here with descriptive analytics. Now, as you can see here, descriptive analytics has the word hindsight on the left-hand side, which means looking at the past. So descriptive analytics is very often about understanding what has happened in the past. Now, if I were to take one word, it would be what, and it would be what happened or occurred in the past. And this is the essence of descriptive analytics. Now, examples might be that the sales dipped by 5% last month. This would be one example of describing something that occurred in the past, but this is a very basic example. There are many more sophisticated things that happen in descriptive analytics. To take some examples, we'll talk about all the reporting that companies do with multiple drill downs involved in the reporting. All of the KPIs and the metrics that are prepared and dashboards that are prepared in different softwares, as well as your exceptions and alerts, your SMS alerts, your email alerts, your software alerts, in-app alerts are all examples of descriptive analytics, because by the time you talk about it, it has already happened. It has already occurred. And that's why we use the word hindsight. If that is clear, the next question is then, what is predictive analytics? And if the one word that describes descriptive analytics is what happened, then the one word that probably would describe predictive analytics would be why it happened. So for example, if sales went down by 5%, why did it go down by 5%? Maybe it's because there's just been an end of a sale period and people made a lot of purchases in the sale period, because of which now the sales has dipped by 5%. Now, as you see here, we're going beyond what happened in the past, and what happened in the past was descriptive analytics. And what happened in the past was that the sales went down by 5%. But we're moving beyond that, and we're moving to why it happened. And we've uncovered the fact, for example, that it happened because of a sale period ending. Now, this would be insight. And therefore, you see on the left-hand side of predictive is insight. All right, so if we're clear on these things, the next question is, what do we do now? And how do we move forward? And so the one word that would summarize the next kind of analytics, which is prescriptive analytics, would be, how do we move forward from here? Answers might include that we need to offer time limited or limited time offers to customers, maybe offers that expire in 24 hours, right? And these could be prescribed by using rules. And so you see that here, rules would be something that human beings design and that are utilized. And you see that here, that is dynamic utilization. But it might also be not rule-based, it might be done with the use of machine learning or automatic decisions by algorithms or computers. But either ways, you're prescribing how you should proceed in the future. And therefore, it's prescriptive analytics. It's also about having insight. Having foresight. All right. Examples would be, for example, in prescriptive analytics is automating the decisions regarding the supply chain, like automating the reordering of certain SKUs or certain products which are about to get stocked out. Examples of predictive analytics might be predicting the products that are about to run out of stock and making sure that we have stock. Because, for example, Amazon might want you to have 90 days of stock if you're a merchant. Descriptive would be tracking KPIs, like how much inventory do we have in different warehouses, for how long has the inventory been in those warehouses, what is the aging around that inventory of products. So if you've got a product in a warehouse for 90 days, it's a pretty long time, but if it's 140 days, it's a really long time. And all of those are KPIs, things that we measure to see how we're doing in our business. And these are examples of analytics. But I'm going to take a step backwards, and I'm going to talk about some things that are a little more fundamental. We all know that analytical reasoning and analytics is in big demand, and that continues to be the trend from 2016 till today at the end of 2019, and I'm sure it won't be very different in 2020. But I want you to understand what are the different types of data variables, and we want to go back to the basics in statistics and make sure that we've got strong concepts around those. Now, one kind of data variable is a numeric data variable. It's a number. And that's what you see here on the left-hand side. Here's your numeric data variable. Fairly easy, it's a number. And so then what is a categorical data variable? Well, you might want to think of it for the time being as anything that is not a number is a categorical variable. Okay, so we can take examples. So if you, to help understand this a little bit better in a very short while. Now, within numerical and categorical variables, there are, subtypes of variables. For example, numeric variables could be continuous, which means they could take any value in a particular range. They could also be discrete. Now, the way people might want to think about it is continuous variables have decimals, while discrete variables don't have decimals. We'll take examples to understand this very shortly. In categorical variables, you have ordinal and nominal variables. Now, you remember that categorical variable is a variable which is not a number. But in that, is there an order? And if there's an order, then it's ordinal. If there is no order, then it is nominal. Now we'll understand this with examples. I'm just going to disable a couple of things here, clear all the drawings. All right. Sorry. All right, here we go. So examples of a continuous variable might be weight. Your weight might be 86.8 kgs, it could be 86.9, it could be 87.2, it could even be 86.887. It could take any value with decimals as well. And the same applies to your height. It might be 157.6 centimeters, 175.8 centimeters, but discrete variables are not like that. For example, if you look at the number of cars that I own, I can't possibly own 3.5 cars, can I? I can own 2 or 3. So it can only take a whole number. It cannot have a decimal. Let's take an example of ordinal and nominal variables. So anything that is not a number is a categorical variable. Now within that, if there's an order, for example, your t-shirts might be small, medium, large, or extra large. There's clearly an order, even though these are not numbers. So these are ordinal categorical variables, while if there is no order, for example, your nationality might be Indian, Korean, or Nigerian, and there's no order, they're all equally good citizenships to have. In those cases, we call it a nominal categorical variable. Now, it's important to understand a concept that a data type is not always equal to a data variable type. So very often you see people equate a data type with a data variable type. Now, these are very different things. A data type in IT, in any programming language, whether it's C, Python, or R, is not necessarily the same as the data variable type. Now, let's understand this a little bit better. For example, you see here some employee IDs, you see the names of these employees, and you see their gender. You notice that the employee ID is numerical, and the name contains characters, and the gender is also character information. Now, these are the data types. They're numbers or they're characters. But the data variable type is actually categorical. It's not numerical, and I'll tell you why. There's one very important definition of numerical variables that we need to understand. The definition is that something which is a number alone is not a numerical data variable. It is also important that there should be some sense in running mathematical operations with those numbers. Only then we consider those numbers a numerical data variable. For example, J's employee ID is 2353. And we also notice that Larry's employee ID is 7574. The question is that these employee IDs, they look like numbers, and if I were to total and if I were to add these employee IDs, would there be any sense in doing that? What I mean to say is, would there be any sense in adding the employee IDs for J and Larry? Sure, it's easy to do. 3 plus 4 is 7, 7 plus 5 is 12, and then 9, and then 9. And so you might come up with the number of 9,927, and you might say that the combination of the employee IDs for J and Larry is 9927. But is there any sense in that? Is there any sense in saying that the employee ID of J plus employee ID of Larry is 9927? Absolutely not. There's actually no sense in doing this whatsoever. So these numbers that kind of look like numbers, they're stored like numbers in Excel or in Python or in R, are not a numerical data variable. They're actually categorical data variables. Because instead of saying J was the first employee or the second employee or the third employee, we give him an employee ID of 001 or 002 or 003. But actually, if you look at it, instead of saying 001, basically it's a short form for first, or the 002 is a short form for second. And if you look at first, second, or third, then clearly you understand that it is not, a numeric variable, it is actually a categorical variable. Okay, so we understand this concept. Similarly, if you have characters, for example, male and female here, it is not necessary that just because they're text that it has to be a particular data type. Let's take this example again. So as you see here, gender is a text data type, but in terms of the type of variable, it's actually a categorical nominal variable because your gender might be male, female, or any other gender, and all of them are equally, okay to have as a gender. There's no bias for any gender. So it's a text data type, but it's actually a categorical nominal variable. All right, so we've understood some concepts around the different types of data variables a little bit better now, and we do understand these 4 types of data variables. Let's move ahead a little bit more and see what else we can uncover in today's session. I want you to understand population and sample, and why we pull a sample out of a population. You see, the entire population, if I were to survey the entire population for a particular outcome, it might not be very cost effective. It might also take a lot of time. Quite simply, it might not even be practical to do. So for practical reasons, instead of surveying an entire population of people, we actually pull out a small sample which represents this population. And we use descriptive statistics to summarize the characteristics of the population by actually analyzing the sample. For example, I might want to figure out what is the average height of all the women in this group, but I might not actually measure all the women. I might measure only 40 or 50 women if that is representing the entire population. And there are different set of methods to make sure that your sample is a representative sample. But the whole idea is that sometimes we run analytics on the entire data or the entire population. At other times, we actually pull out a sample and run our analytics on the sample. We infer what the whole population is like by using the sample, and this is called inferential statistics. In terms of the types of data analysis, there are one popular classification is a uni, bi, and multivariate analysis. Quite simply put, a univariate analysis is when you analyze one variable at a time. For example, how many students are graduating with an analytics degree? So it might be 20, it might be 40, it might be 50. Or for example, what's the average height of women in this class? It might be 163 centimeters. And that's just one variable, the average height. In fact, I should just say the average height of students in this class, not women, because that would be bivariate, because you then have to look at the men and the women. Now, let's look at bivariate. Bivariate is, for example, what's the relationship between the number of steps I've walked and my weight over a period of time? So is there a correlation? Are the number of steps I'm walking impacting my weight or not? All of you know there are fitness apps that capture the number of steps that you walk, and this is a simple bivariate analysis you could do. Multivariate analysis is a little different. And I'll talk about multivariate analysis now from this point onwards. Multivariate analysis is when more than 2 variables are analyzed for any possible association or interactions. Let's take an example. What could be the relationship between the number of steps I've walked, the number of calories that I've consumed, and my weight? That would be an example of a multivariate analysis, which involves more than 2 variables. A data scientist has a pretty complex role. He or she has to do a lot of things, but I think the top 3 are discover actionable insights in a particular data set and define the problems that can be solved with data in partnership with your business or your clients or your stakeholders and not alone. Also, choosing the right techniques or a combination of techniques, because it's not always one technique that gives you the right results, in order to solve a given business problem that you've defined. Finally, today expectations are also about implementing this. Now, here I want to qualify that this is not in isolation. So I would not like to say that a data scientist implements all of this alone. It is actually in partnership with IT or tech teams, with business, and in fact, sometimes other external stakeholders as well. However, you do need to have a lot of concepts, such as a variety of tools. You should expect in the world of data science to have to work on a tool of the choice of the client. It might be R, it might be Python, or, and I say client, but it might be an organization. In visualization, it could be Power BI, it might be Tableau. And so you don't necessarily get to choose. You've got to be able to work on a variety of tools. The size of the data might vary from as small as, let's take images that you get from WhatsApp, right? And those may be really small. They might be even 40 KB size of memes, right? All the way till 40 terabytes of data, which is really, really large data. And you've got to be able to handle all of that. But the idea is not to do it in isolation. It is also to be able to do it really quickly. And so what matters here is the efficiency and the speed. The speed is very important, and which is why people need to optimize their analytics models in partnership with the tech team or themselves, as well as look at the cost. So how do you use the right cloud options so your cloud bills do not balloon up? Or what could you achieve locally in a cheaper fashion before you actually put it up on the cloud, right? This is another consideration. Of course, the data scientist partners with a lot of people. So one of the notions that I think a lot of people carry is that data scientists are people that do all of this that you see here, right? And they do it all alone. But that is not actually true. They partner with a variety of people, so partnership is important. Now, finally, supply chain analytics. I just want to touch upon this a little bit. Supply chains have become really, really complex. If the 80s were about just in time, they were about TPM, quality, Kanban. Today, it's all about real time decision making on the supply chain rather than deferred decision making. So, supply chain analytics tries to further improve the efficiency, effectiveness, bringing data to the center of decisions that are being taken in supply chain rather than old Excel sheets. And supply chain analytics is also about bringing a data-driven culture to the business, acquiring data at every step in the supply chain as the inventory moves from raw material right till the finished product that hits the customer. How do you capture data all along the way, reduce cost and improve service the customer, service levels for the customer while maintaining cost and improving delight, and that is supply chain. And we've sort of given an example here where you talk about how do you establish and capture physical world information from a factory here, which you see on the left hand side. And we call this in the world of analytics data acquisition. So how do you acquire data at the source, right, and then analyze and visualize it? Now, mind you, you want to visualize before you analyze, right? Sometimes you get very good trends out of visualization. And then finally, how do you have algorithms or decision-making frameworks by using different models? And all of this today, the interaction between the physical and the digital worlds is happening through analytics and through automation as well. Let's equally give credit to automation. And this is a little bit more about supply chain. Now, we're really excited about learning more together, and we'd love to meet you. You can email us at contact@EquiSkill.com, and this is our address. Thank you so much for attending this session with us. Bye-bye.